Okay, so good evening, everyone. As you already know, my name is Rahul Kumar, a PMRF scholar from IIT Madras, and I am delivering engineering mechanics lecture. And in this week, I will talk about friction. Okay, so let's move to the one note. So, uh, in previous lectures, we assumed that we assumed that surfaces in contact are actually frictionless, but in nature no perfectly frictionless surfaces actually exists. So if surfaces in contact are rough, then tangential force can develop which prevent the motion of one surface with respect to other. So what can you write? In nature in nature, no perfectly frictionless frictionless surfaces exist. Okay, so so if surfaces in contact are rough, okay, then what will happen? A tangential force a tangential force a tangential force can develop, okay, can develop which prevent which prevent the motion of one surface with respect to other with respect to other. And this and this tangential force is called friction force. Okay, so when I'm saying that when surface is rough, and if you apply an external force and you want to move any object, then there will be a tangential force which act in opposite direction of your external force, which will prevent the motion of one surface with respect to other. Okay, also also friction force are always, this point is very important, are always limited in magnitude, limited in magnitude, which means which means if you apply sufficiently large external force, then friction will what? Can you tell me what will happen?
It will start to move.
Yeah, will not prevent, okay, will not prevent the motion. Okay, okay, so what does it mean? What does it mean? It means it means frictionless and rough surfaces are just a matter of degree. Okay, matter of degree. Are getting my point? Tell me.
Yes, sir.
Yeah, so yeah, in practical there are two types of friction force. There are, actually my writing is very bad. There are two types of friction force. Okay, the first type is called dry friction.
So what is matter of degree?
What? I'm saying that it's just a matter of degree, means I'm talking about the magnitude. Okay, so you cannot say that the surface is perfectly rough, and you can also not say that the surface is completely, I mean, perfect frictionless. So I'm saying that the surface is just a matter of degree. It means if you apply a huge amount of external force, then definitely any object will move. Okay, so that's what I'm talking about. It is just a matter of degree. You cannot say that any surface is perfectly rough, and you can also not say that the surface is completely or perfectly frictionless. Okay, so there are two types of friction force. The first is dry friction, or you can also say that Coulomb friction. Coulomb friction. And second is called fluid friction. Fluid friction, or viscous viscosity, not viscous, viscosity. Okay, and in our present study we will talk about only this, not this, because you will study this part in where, tell me.
Fluid matter.
Yeah,
Fluid
fluid
mechanics.
mechanics. Okay, fluid mechanics. So fluid mechanics. Okay, so let's move to the laws of dry friction. Laws of dry friction. Okay, so let's talk about, let's take one example. Okay, suppose there is a surface and there is a block which is resting on this horizontal surface, and this surface is actually rough. Okay, so what will happen, tell me. If the block is resting on this surface and suppose the block has weight W, what will happen? Will it move or not?
Not sir.
Yeah, it will not move. Okay, because there is no horizontal force. You are not applying any horizontal force, and in the vertical direction the horizontal surface will apply a normal reaction N, and by the weight of the block there will be force vertically downward, and here W will be balanced by the normal reaction. That's why the system, I mean the block, will be in equilibrium. So that's why there is no motion. Okay, now let's take another case. Okay, again you have a horizontal surface and there is a block of weight W. Now here you are applying a force in horizontal direction P, and this surface is again what? Rough. Can you tell me what will happen?
May or may not move.
Yeah. Okay, so here we will introduce a force which is called horizontal force, I mean tangential force, and also you can say that is a friction force. Okay, so what will happen if you create FBD and here a force P, and here the weight W, and since the block is resting on the surface, so the surface will exert a normal reaction N. Since you can see that W will be balanced by the normal reaction, but here the external force will not be balanced by any force. So the block may move towards this direction, but here the surface is rough. So this rough surface will do what? it will exert an opposite force and in opposite direction, which is called friction force. So here we are first introducing friction force in the first time. Okay, so now the question arises, the block will move or not. So here you cannot say that the block will move or not. Okay, so it depends on the regularity. I mean, they depend on the roughness, or you can say the irregularity of the surface. Okay, so if you want to move the block in this direction, then you have to overcome this force. Okay, and in the experimental evidence, people says that if P is balanced by the friction force, then the block will not move, and if P overcomes the friction force, then the block will start move. Okay, so what I am trying to say, if you draw a graph, I'm trying to say, if you draw a graph of friction force F and external force P. Okay, so the nature of friction force says that every time when you apply P, it will be balanced by the friction force F. Okay, and it depends on the capacity. It depends on the capacity of the roughness, which means the force P will exactly balanced by the force F, which means every time when you apply the external force P, which will be balanced by F, but after certain time, I mean after certain extent, the force P will not be balanced by the force F, which means after that certain time the force P overcomes F, and I mean that amount of force P, which is called maximum limiting frictional force. And if you draw the diagram of P versus F, and you will get this type of diagram. It says this type of diagram. It says in this region, it says in this region, every time when you apply F, every time when you apply P, it will be balanced by F, which means in this region P will be exactly equal to what? F. But after this point, the capacity, I mean the capacity will be finished. I mean the roughness will not, the force will after this the external force will overcome F. Then what? The capacity of F will be finished, and after that the block will start move, which means after this point, the surface, this surface cannot exert exactly equal to the force P. Then what will happen? The block start move. But after this point, after this point, you know what will happen? After this point, the magnitude of the external force, drop by some amount, and after this point the exactly constant amount of friction force will act. Okay, I mean there is no such variation of friction force. Okay, so at this point, and this limit is called limiting friction force. Limiting frictional force, and you will denote by Fs. Okay, and this frictional force is also called maximum force, maximum frictional force. But after this point, when you apply the external force after this amount, then the frictional force will drop, and it will become constant. Okay, and so this, I mean after this point, it is called kinetic friction. Okay, kinetic friction means the block will start move. Okay, so after this point there will be some reduction in frictional force. there will be some reduction in frictional force, and after this point the amount of friction will remain constant. Okay, so if you apply force in this region, if you apply external force in this region, the block will always remain equilibrium, but after this point the block will start what? Move. Okay, so this is called what? Limiting limiting frictional force, also called static friction, and after this point the amount of friction is called kinetic friction. Are you getting my point? Tell me, have you written
Yes,
it?
sir.
Yeah. And one more thing I want to mention, suppose if you apply external force P here, not exactly about the center of gravity. I mean, if you suppose the block is in regular size, suppose if you see in the from the front view, suppose it is a rectangle, and if you apply not along this line, okay, and if you apply the force at some distance, okay, so what will happen here? The weight will be like this direction, and the friction will be along this direction, but you cannot say that the normal reaction will exactly along this direction. Why? Can you tell me why? Tell me, are you getting my point, what I am trying to say?
Because of moment.
Yeah, yeah, suppose if you apply external force not along this direction, you are applying external force at some distance, okay, I mean some distance, suppose it is a distance E, and here the weight is along this direction, friction is in this direction, then you cannot say that the normal reaction will exert exactly in this direction. It will exert at some distance, because if you suppose the block is in equilibrium, okay, suppose the block is in equilibrium, then definitely this force, the external force, will be balanced by the friction force, okay, and in vertical direction the weight will be balanced by the normal reaction N. Okay, so here the force equilibrium is exactly maintained, but here the moment is not maintained. If you if you try to maintain the equilibrium about this point, then what will you see? You will see that the due to this external force, the moment will be in this direction, okay, and there is no contribution by the weight, okay, and this force and this frictional force, by these two forces, the contribution of moment will be in this direction, but this moment will not be balanced by the by another force if you apply the normal reaction directly along this direction. So you have to, I mean, the normal reaction has to shift in some distance so that it can maintain the moment equilibrium. Okay, so that's why always if the width, if the width of the block is some definite, it is, if it is not a particle, so suppose it is a rigid body and it has some dimension, then definitely the normal reaction has to shift along this direction to maintain the moment equilibrium. Okay, and suppose uh suppose it is a point A, okay, suppose it is a point A and it is a point B, okay, and you are trying to increase the amount P, okay, you are trying to increase the amount P, then what will happen? The N will start shifting from point A to B, and suppose before finishing the maximum limit, N is already N is already reached to point B, then what will happen? Before reaching the limiting value of P, and before the reaching the limiting value of P, A already arrived at point P, then what will happen? Can you tell me?
The
Tipping.
block topples.
Yeah, it will tip off, okay, if if N already arrived at B, okay, before reaching reaching the limiting value of F, okay, then block will topple, will topple or tipping, tipping off. Okay, so this point you have to remember. But you know, after some time, I mean, in the whole friction in this whole friction chapter, I mean, in this week, we will not talk about the finite dimensional block. We will assume that the block is in what? Particle size. When you study the rotational motion, then you will be able to assume that the block has some certain dimension. But up to this point, you have to assume that the force P, either you have to assume that the force P is exactly passing through the center of gravity, or you have to assume that the block has very negligible dimension, or you can say that the block is what? Particle. Okay, so let's move.
Sir,
Yeah, yeah,
Sir,
tell
sir,
me.
a limiting value of F means like it should be equal to the external force apply.
Limiting value, I'm saying that suppose limiting value, I'm talking about Fs. Limiting value, which means it has lost the capacity of to maintain the equilibrium. I mean Fs. I'm talking about Fs.
Yes.
Yeah,
Sir,
yeah. Tell me.
the distance between the weight acting and the normal reaction equal to E, sir.
I'm not getting your voice clearly. Can you tell me again? Can you ask me again?
The distance,
What?
the,
What?
the force is not passing through the center of gravity of the block, sir, in horizontal direction.
Yeah,
It passing through the eccentricity of E.
yeah,
The normal direction is also not passing through the center of gravity in vertical direction. It passes to the some distance.
yeah, yeah.
Some distance, some distance is equal to that eccentricity or not, sir.
I will repeat it again. I am saying that if force P is not passing through the line of center of gravity, if force P is not passing through the line of center of gravity, then definitely this force, I mean this normal reaction will not pass through the center of gravity. If it is passing through at somewhat distance, then N has to shift from its the center of gravity to maintain the moment equilibrium. Okay, is there any
Okay.
doubt? Tell me.
So even if it passes through the center of gravity,
What, what?
even if it passes through the center of gravity,
If it is passing through the center of gravity, then N has also, I mean, here you have to see the equilibrium situation. I mean, here F is also applying the moment. Okay, so you have to, I mean, here the situation, whether N, how much, I mean, at what distance the N will shift, it depends on the magnitude of the moment contribution by P and F, not only the P, because here the moment contribution is because of P and F also, not only by P. Is it clear?
yes.
Yeah, not only the P. Okay, so let's move further. So so here now I'm one more thing I want to tell you. Here the situation where the friction force, when the friction force is exactly equal to the limiting frictional force, the at the situation, I mean here F and P is exactly, when P is exactly equal to Fs, this situation is called impending. And after this the friction will be called Fk. Okay, kinetic friction. And after this the block is in motion. Okay, so let's move further. After after experimental evidence, it says that Fs, I mean limiting frictional force, which is also called static frictional force, is directly proportional to the normal reaction. And when you remove the proportionality, then proportionality constant will come into the picture, which is also called mu s into n. It is called static coefficient of friction. Coefficient of friction. And also the kinetic friction is also directly proportional to the normal reaction, and when you remove the proportionality, then another constant will come into the picture, which is called kinetic coefficient of friction. Kinetic coefficient of friction. Okay, so here mu s and mu k does not, okay, does not depend on the area of surface in contact. Okay, but it depends on the nature of surface. Okay, nature of surface. Okay, this point is actually very important. So what I'm trying to say is that the mu s and mu k is actually the what? Surface property. Surface property, not the amount of area. Okay, so here, is there any doubt? Tell me.
No, sir.
Yeah, so now let's move to the different types of situation. Different type of situations. Different types of situation. Okay, so situation number 1. Okay, so suppose there is a horizontal surface and block is resting on the horizontal surface, and you are applying an external force which is exactly in the vertical direction and passing through the center of gravity. Then what will happen? Here the surface will exert a normal reaction N. Okay, and here, because of the weight, here you don't confuse, because here I am trying to say that N is exactly passing through the center of gravity, and if I exactly draw along the line, then you will be confused. That's why I'm showing by some certain distance. Okay, so don't confuse with this. So here the weight is W, and because of the external force P, the direction is here. So this is the ABD. Here you can see that there is no any external horizontal force. So the friction will not come into the picture. So the system will remain in equilibrium. Okay, so what will happen? Here, if you apply the vertical equilibrium, so N will be exactly equal to what? P plus W. So there is no motion. So this is the condition number 1. Now move to the condition number 2. Suppose there is a block. There is a block, and now you are applying an external force in this direction. Okay, and the block has some weight W. So what will happen here? So suppose you are applying an external force in some angle. Okay, suppose this angle is P. Sorry, this angle is theta. So if you resolve this external force in two components, then this is will be what? This is will be what? Px, and this will be Py. And if you draw FBD, then there will be Px, there will be Py, and there is a weight W, there is a normal reaction N, and since you have applied a horizontal force Px, so definitely to oppose this horizontal external force, the friction will come into the picture. Okay, and if if Px is less than Fm, then what will happen? Tell me. Tell me what will happen if Px is less than Fm.
Body will not move, sir.
Yeah, no motion. Okay, and if Px is equal to Fm, then this condition is what?
Impending motion.
Yeah, impending, or you can say just about to slide. And in an appropriate word, you can say what? Impending. Impending. And px if px is greater than fm, then what is the situation?
In motion.
Yeah, in this situation the block will start moving. Will start moving in motion. Okay, so when px is greater than fm, then in that situation f is exactly equal to what? In that situation f will be exactly equal to fk. When px is greater than fm, then at that situation you cannot say that px exactly equal to fm. Here, after the limiting, after the crossing the limiting point, then there will be a constant frictional force that is equal to what? Fk. Okay, so is there any doubt here? Tell me.
No, sir.
Yeah, now let's move further. I will say let's do some example. Okay, sir, then we will move further. Can you solve this problem, or should I solve this? So let's solve this problem. Okay, after that we will move further. Solve this problem. Very easy problem.
Newton.
Yeah, yeah, that is correct. So what is happening here? If you draw an FBD, so here 10 Newton external force is applying, and here N, and here 10 into Z. Okay, so first you have to check whether what is the limit of friction. Okay, what is the maximum limit of friction? So what is the maximum limiting force? Mu mg, or from where mu mg comes? Here n equal to mg. Okay, so fm equal to what? Mu n. Mu n. Here I am writing n equal to mg because the block is in vertically equilibrium. Okay, so here n equal to mg, that's why I am writing n equal to mg. Okay, so here it is saying that the coefficient of static friction between the floor and the block is 0.2, so you have to substitute 0.2 and mg into 10 into 9.81. Okay, so yeah, so here what is the value? What is the value here? What is the value here?
19.62.
Yeah, 19.6 Newton. So here you can see that the maximum limiting force is 19.6, but you are applying only 10 Newton. And I told you that when the external force is less than the maximum limiting force, then the frictional force will be exactly equal to the external force. Okay, so don't confuse that. Here fm is 19.6, which means that the magnitude of friction force will be exactly equal to this. No. Okay, so up to the maximum limiting, here external force will be exactly equal to the frictional force. Okay, when you apply the magnitude of the external force is larger than this, then you can say that the frictional force will be not, I mean, I'm not saying that the frictional force will be exactly equal to this. I mean, when the magnitude is larger than this, then what will happen? Then at that time the kinetic friction will come into the picture. But here the external force is less than the frictional maximum limiting force. So in that situation, the friction force will be exactly equal to the what? External force. So what is the answer? Only 10 Newton. Okay. So let's move to this problem. Yeah, is there any doubt? Yeah, is there any doubt? Tell me. So let's move to this problem. Is it in equilibrium or not?
Is the crate under motion?
What?
Not in equilibrium, it is moving.
Yeah, it is moving. What is the value of friction?
16.
16. No. Check it once again. Maybe you are doing some mistake. Okay, so let's solve this. In the problem of friction, first you have to find the magnitude of kinetic friction and static friction, and that is the actually smartest approach. So first you have to find what? Fs. So what is Fs? So mu s into n. Okay, and what is Fk? Mu k into n. Okay, so but here n is not equal to mg. Okay, so 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 when you draw the FBD, here weight is what? W.
Friction 47.99.
What?
47.99.
67.
47.
Yeah, 47.99. Yeah, it is correct now. So when you resolve W, if W is the weight, so that is W cos theta and it is W sin theta, and here the normal reaction is N. So here N is equal to what? W cos theta. Okay, so mu s into W is 300 into cos theta. Okay, so if it is a theta, then cos theta will be what? 4 by 5. Okay, so when you put mu s, the value of mu s, you will get 60 lb, and here when you put the value of mu k, so that is 0.2 into 300 into 4 by 5, you will get 48 lb, right? Now you have to check, whether the block is moving or is in an equilibrium. So here you can see that the weight, because of the weight, so that is the weight. What is the weight? 300 into sine theta. I mean, because of the weight, there is a component in this direction. So that component is what? W sine theta. So W is 300, and what is the sine theta? Perpendicular divided by hypotenuse. So that is 3 by 5. So 60 times into 3, that is 180. Okay, 180 lb, and the external force is what? 100. Okay, so you can see that you are applying external force that is only 100 lb, and because of the weight, the block is going down by 180. So definitely there is external force. So there is a net external force which is directly into the downward direction, and that amount is what? 80 Newton. So the net, F net, there is a F net, and what is what? That is what? 80 lb, and that is in this direction. Okay, and here, what is the maximum limit of the static friction? That is only 60, but here the external force is what? F net, that is what? 80 lb. So definitely external force is larger than the static force, which means the limit is finished. That means the limit of friction is finished. So definitely the block will start moving downward direction, and in that situation the kinetic friction will come into the picture. So in that situation, the friction will be what? It will be in direction that is equal to 48 lb. So what is the value of friction force? 48 lb. 48 lb. Is there any doubt? Tell me. Is it clear or not? Hello?
Yes, sir.
Yes.
Yes, sir.
Yeah, is it clear?
Yes, sir.
Yeah, now let's move further. Now let's talk about angle of friction. Angle of friction. Angle of friction. Okay, so suppose there is a block. Suppose there is a block which is resting on the horizontal surface, and you are applying external force P. So because of that, there will be two components, that is Px and Py, and because of the weight, that is W, and if you create FBD, so there will be two situations, that is what? Px and Py, and here the normal reaction, and here it is a weight. Okay, so since you have applied external force, then there will be frictional force. Now here you can see that if you take, I mean, if you want to consider the resultant, if you want to consider the resultant between the normal reaction and F, okay, if you consider the normal reaction, I mean the resultant between the normal reaction and F, then what will be the magnitude? And the resultant will be what? R. Okay, and if the angle between the resultant, suppose here the normal reaction is what? N. Okay, and the friction is what? F. Suppose N, suppose N is the magnitude, so not magnitude, N is the resultant between N and F, and the angle between, oh sorry, that is R, and if the angle between N and R is phi, then what will happen? What will happen if 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 f if f equal to px? Okay, if f equal to px, oh wait a minute, someone is at my door. Wait a minute. Yeah, are you getting my voice? Hello?
Yes, sir.
Yeah. Suppose f is exactly equal to px. Okay, so what will happen if f is exactly equal to px, and suppose f is equal to fs, f is exactly equal to fs, then this is what, this is the condition of impending. And if the condition is impending, then you can see that it is a limiting case. Okay, it is a limiting case. It is a limiting case. So here phi will be what? Here if you draw, since you have drawn drawn this triangle, and if you take tan phi, then what is the will be the value? Tan phi equal to perpendicular divided by base. So here f divided by n. And since you have considered that if f is limiting, if f is the case of limiting, then f will become what? Fs. And if f is fs, then that is equal to fs. And if f is fs, then you can consider that phi is equal to what? Phi s. Then you can write tan phi s equal to, at the place of fs, you can write mu s n and divided by n. N will be cancel out. Then you can say that tan phi s equal to mu s. Tan phi s is equal to mu s. And here phi s is called angle of static friction. And you know, there is a meaning of this. And the meaning is, if here the meaning is, if you can clearly see that if phi, I mean this angle, okay, if this angle is less than, if this angle is less than phi s, then you can say that there is no motion. Okay, and if phi equal to phi s, I mean this angle, and that phi s is nothing but tan inverse mu s. Here phi s equal to tan inverse mu s. If phi equal to phi s, then it is a case of impending. And if phi is greater than phi s, if phi is greater than phi s, then what? There will be motion. And in that situation, phi will be equal to phi k. Okay, and that phi k will be what? Tan inverse what? Mu k. Okay, is there any doubt here? And what is the meaning? I mean, I am trying to say that if phi is less than phi s, what I'm trying to say, if phi is less than phi s, if phi is, if phi is less than phi s, which means that, that there is no motion, which means that there is no motion. And in at that situation, px is exactly equal to what? F. And if you are increasing phi, if you are increasing the phi, then what will happen? This magnitude will start, this magnitude will start what? Increasing. Okay, this magnitude will start increasing, and there will be a limiting case where f is exactly equal to fm, and that limiting case is called what? Angle of static friction. And when you increase further, when you increase the amount of force further, then what will happen? The block will start moving, and at that situation the magnitude of friction will reduce by some amount, and after that the friction will be equal to kinetic friction. Okay, and at that situation phi will be what? The phi will be exactly equal to mu k. And after that, that amount, there will be no change in phi. Okay, after that the angle of friction will become constant. Okay, so in this situation only, when you increase the amount of external force, there will be change in phi. But after this point there will be no change in phi. Okay, because after that the f will be constant. That's why the phi the angle phi will remain constant. So the limiting situation, the limiting case phi is called what? Angle of static friction. Tell me, is there any doubt?
Sir, if phi less than phi s, then why no motion?
What?
First case, sir, phi is less than phi, yes, then why no motion?
Yeah, if phi is less than phi, I'm trying to say, then in that situation, the friction force will be exactly equal to px, no? The friction force will be exactly equal to case. In that situation, I mean, that situation is this. I mean, the block will start moving after this situation, right? After this point. If phi is less than phi, then that situation is this, where px is exactly equal to the friction force. Okay, so when you further increase the external force, then the friction will reach at this point. Okay, and this point is called what? Impending. And when you increase further, then the limiting friction force will reach to the what? I mean, the amount of friction will be becomes what? Kinetic friction. Okay, so after that point, there will be no change in phi. Okay, tell me.
Yes, sir.
Yeah. Now let's move to the second case. I mean, this situation is when block is resting on the horizontal surface. Okay, what will happen when the block is resting on the inclined surface? Okay, suppose the block W is resting on the inclined surface, and again there is a mu s and mu k. Okay, so what will happen here? Tell me. What will happen here? Suppose this angle is theta. Let me start from the beginning. I'm jumping directly here. Let me start from the beginning. Suppose the block is resting here, okay, and suppose the angle between the block and the surface is theta equal to 0. Then what will happen? Here there is a no motion, right? There is a no motion because there is no horizontal force. Okay, but when you increase the angle, when you increase the angle, okay, suppose this angle is theta, then what will happen?
Body slides down.
No, you cannot say directly. It depends on the friction force, okay, the amount of friction. So here that will be W sine theta, and that is W cos theta, and suppose the friction, the amount of friction is W. Okay, so if 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 you are increasing the theta up to some limit, if you are increasing theta equal to up to some limit, such that f becomes fs, okay, and for that reason, if f becomes fs, then what will happen? Mu n, and here, I mean, mu s n, and here n equal to what? N equal to W cos theta. Okay, so here f equal to what? Mu s W cos theta. Okay, and here n equal to what? N equal to W cos theta. When you divide these two equations, then what will happen? Tan theta equal to what? F by n, right? And here, since you have increased theta such that it reaches to theta equal to theta s, then in that situation, f is equal to what? Mu s W cos theta. So mu s W cos theta divided by what? Wait. Yeah. Mu s W cos theta, n equal to what? W cos theta. W cancel out. The cos theta cancel out. Then tan theta s becomes what? Mu s equal to what? Mu s. And here again, if theta is less than theta s, then what will happen? No motion. Okay, when theta is equal to theta s, then what will happen? Case of impending. When theta is equal to greater than theta s, then what will happen? Motion. Okay, and in that situation theta becomes what? Theta k, that is nothing but the tan inverse what? Mu k. Okay, is there any doubt? Tell me.
No, sir.
Yeah, so look at this, okay, for a minute, then we will start some example. Okay, have you noted?
Yes, sir.
Yeah, let's move to the one example. Yeah, let's solve this problem. Not this. First I will do one thing. Suppose first I will do one thing, then we will go to the that problem. Okay, that's
Sir, which means this theta and the previous angle phi both are same, sir.
what theta and theta k what? No,
No,
here,
sir.
no, here
Theta
theta,
s and
here theta is actually this inclination angle, and here theta is,
magnitude.
yeah, here theta is the angle between n and r. Okay, here phi, here it is a phi, here it is a theta, so both are different. Okay, so don't confuse with
So
this.
when the magnitude is same, they'll be
So
impending
yeah,
motion.
definitely magnitude it's same. Both are same. Definitely mu s and mu k. But here the meaning are different. Meaning are different. Here theta is actually the inclination angle, and here the theta is, the phi is the angle between r and n. So don't confuse this with this. Okay. Should I move
Sir,
further?
but
Yeah.
sir, at limiting condition, theta becomes phi, na?
Theta, yeah, actually, the situation, both situation are same. Here when you either you can rotate this plank, or either you realize that the angle between these, okay, both are same. If you interpret, if you interpret, the both are same. Okay, because here you are rotating this surface by angle theta, and here you are rotating the vector. So bo physically both are same, but interpretation are different. Okay, here you are assuming phi is the angle between r and n, but here theta is angle between these two surfaces. But here again, here phi is again angle between what? R and n, and here you can also assume that the phi theta is angle between r and n. Okay, either you can incline this surface, or you can steep this surface, or you can rotate this vector. The meaning, in both cases are same. Okay, but interpretation are different. Here I'm
Sir,
talking.
how can we correlate between this rotation and this reaction angles?
Here I'm saying the correlation is, suppose I'm talking about this. Okay, so here I'm doing what? If you realize the block is like this, if you realize the block is like this, then what will happen? Again, either you can say that the angle phi is like this, or phi is like this. If you incline the block like this, along the perpendicular to the reaction force, this resultant force, in both case situation are same. Either you can rotate this block, or if you put, either or you can put the block like this. Okay, so here it is a reaction, it is a resultant. Here the resultant is normal force. Okay, tell me.
So please repeat the point, last one.
I am saying that saying that here I am assuming phi is what? Phi is the angle between resultant force and n. Okay,
Yes.
and suppose in this triangle, is this triangle, right? It is a R, here N and F. Suppose you are realizing this block like this. Okay, realizing the block like this. So here it is angle phi, right? And if this is a
Yes.
phi, then this is also a phi. Now both situations are same. Now both situations are same.
Yes.
Yeah. Okay. So that's why I'm trying to say that interpretation are different. But when you realize, I mean, when you imagine things, then you can say that both situations are same. Either you can rotate the surface or either you can rotate the vector. Okay. You will
Yes,
get the
sir.
same. You will get the same result. Okay.
Sir, which means, like, for example, for a fixed theta, like, for example, we are placing it on a wedge, like, theta is fixed. And if we are increasing this F value, like, by increasing the external force, that means we are automatically increasing the phi value to equal to theta. No, sir?
Yeah. Yeah, you are getting correct.
Yes.
Yeah. Okay. So let's move further. Okay. Suppose there is a situation like this. Suppose there is a situation like this, and here there is a block. There is a block. Okay. Now you are applying a horizontal force P. Okay. And the block has weight W. Okay. You can say that like this. Okay. So if tan theta s equal to mu s, okay, this is a very important case. uh, in GATE exam, actually they have asked many questions regarding this situation. So suppose tan theta k equal to mu k, and saying that determine the force P required to, first condition, required to the block start the block up the incline. Okay. And the situation B is keep it moving up, and C is prevent it from sliding down. Derive this problem. I'll give you 2 minutes. Okay. It is a start the block. Okay. Start the block up the incline. Okay, so let's create a FBD. So this will be what? P sine theta, okay, and this will be what? P cos theta, and this is what? W. I'm writing it correct or not? It is a
So actually, it will be P sin theta. No, sir. P cos theta will be
yeah,
this.
yeah, yeah, yeah. Okay, if it is a P, that is a P cos theta, right? It is a P sin theta, and here it is a W sin theta and W cos theta, and here normal reaction is like this. Okay, so I'm not drawing any direction of frictional force because we have to consider three situations, right? Okay, so the first situation, it is saying that the force P required to start the block up the incline. Okay, we want to start the block up. Okay, so if we want to move the block up, then what will happen? If we want to move the block up, then what will happen? Then in that situation, P cos theta, okay, P cos theta must be greater than W sin theta, right? Tell me.
Yes, sir.
And if P cos theta is greater than W sin theta, then block will start to move up. And if the block will start to move up, then friction will act down. Okay, then in that situation, friction will act down. So what will happen? So here it is a W sin theta, here P cos theta, and here F. Okay, here we want to just start the block. So here F must be what? F must be limiting. So what will happen here now? Then P equal to what? W sin theta plus Fm. Okay, now if we maintain the equilibrium in this direction, then what will happen? Then you can see that n equal to P sin theta plus W cos theta. Okay, now from this equation you can see that sin theta plus Fm equal to what? Mu s. Okay, because we do not, I mean, the situation is just about to start, so it is a static equilibrium. Okay, so mu s what? Mu s n. So here n is what? P sin theta plus W cos theta. Okay, so when you move P here, then you will get 1 minus mu s sin theta equal to W sin theta plus what? Mu s cos theta. So here P equal to W sin theta plus mu s cos theta divided by 1 minus mu s sin theta. Okay, now divide numerator and denominator by cos theta, then you will get here tan theta plus mu s divided by 1 minus mu s. Sorry, here I'm doing some mistake here. What? Cos theta. So yeah, so mu s
Yes, sir. P
tan,
cos theta.
tan theta, right? Now mu s equal to what? Mu s equal to tan theta s. So W tan theta plus tan theta s 1 minus tan theta into tan theta s. Now we already know the formula of tan A plus B. Okay, so this will become what? This will become tan theta plus tan theta. Okay, Tell me. Is there any doubt?
No, sir.
Yeah.
Sir,
Yeah, tell me.
in place of P, it is P cos theta.
Where?
Sir, in the starting, P is equal to W sin theta plus F.
Hmm.
P cos theta is equal to W sin theta plus Fm.
Oh, oh,
It's
oh.
okay.
Wait. Yeah, I'm doing wrong here. Yeah. Oh, yeah. P cos theta. That's why I'm dividing, right? P cos theta. P cos theta. Here it is a cos theta. Okay. Here it is a cos theta. That's why when I dividing by cos theta, then it becomes 1, and here it is a mu s tan theta. Okay. Now it is a correct?
Yes.
Yeah. So it is a case A. Okay. Now let's move to the case B. What will happen in case B? Can someone tell me? If it is saying that keep it moving up, then what will happen?
Does the kinetic friction come into picture?
Yeah, the kinetic friction will come into the picture. So in that situation will become what? Fm become Fk. Okay, then everything will become same. And here W equal to tan theta plus theta k. Okay, everything will be same except here Fm will become Fk and mu s will become mu k, and everywhere where mu s will be replaced by mu k, and here mu k is equal to what? Tan theta k. That's why P becomes W tan theta plus theta k. Now let's move to the part C. In part C, it is saying that prevent it from the sliding down. What will happen in this situation if we want to prevent it from the sliding down?
Then, sir, both are equal.
Hmm? If we want to prevent it from the sliding down, then what will happen? If we want to prevent it from the sliding down, which means what? The direction of friction will get reversed. Tell me, are you getting or
हाँ
not?
sir.
Yeah,
हाँ हाँ हाँ.
yeah. In that situation, everything will remain same. I mean, here it is a W sine theta, and here it is a P cos theta. But in this time, the direction of friction will get reversed. Okay, so it will become Fs. Okay, so what will happen here now? P cos theta plus Fs equal to W sine theta. Okay, so P cos theta equal to W sine theta minus Fs, which means mu s into P sine theta, P sine theta plus W cos theta. Okay, now take P as a common, so P cos theta plus mu s sine theta equal to W sine theta minus cos theta. Then you will get P equal to W tan theta minus theta s. Tell me. Tell me, is there any doubt?
No, sir.
Okay, so if there is no doubt, then let's solve this problem. Let's solve this problem. If you know that concept, then you can easily solve this problem. Just it is a one-liner problem. it must be here, it must be slide down. What will be the answer?
Sir, 0.1729
Yeah,
ऐसा कुछ आ रहा है.
yeah. So we will apply this formula, right?
Excuse me, sir.
Yeah, tell me.
Sir, in case A and case C, we got the same formula.
No, 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 those are not same. Case, no, that is a plus, and here it is a, oh yeah, no, no, yeah, that is a theta s, it is a theta k, here theta minus theta s. Okay, so all are different.
Oh,
Okay,
yes.
yeah. So what is the answer for this? Here at the place of w, it is given 900. Okay, and at the place of p, it is given 750. So it is a 900 tan theta equal to what? 30 degree minus theta s. Okay, so tan 30 degree minus theta s equal to 75 divided by 90 equal to what? 30 minus theta s equal to tan inverse 75 by 90, and you will get theta s equal
Sir,
to 0.2. I mean, no, 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 not 0.7. I mean mu s.
excuse me, sir.
Yeah, tell me.
Sir, since we are having negligible mass and having a vertical force, we are assuming it as W.
Yeah, both situations are same, right? Because either you can assume the vertical force or you can assume the weight of this block. What is the difference? Weight is also
Yes, sir.
passing through the gravity. Okay, so both
Okay.
situations are same. What we are getting here, theta s, can someone tell me?
Near about 40 degrees, sir.
75 divided by 90. Yeah, 39 point something, right? So minus, if we subtract, so we are getting 9 point something, right? Theta is equal to 9 point,
9.8.
9.8055. Yeah.
yeah, 9.80 degree. So what is the mu s? Mu s equal to tan theta s. So you will get 0.17. Okay, so that is the answer.
Minus 0.7 means అంటే slides downward side.
What?
Minus 0.71 means
How it is a minus? Okay. You are getting minus, right? Okay. Yeah. Actually, here, theta s must be theta sign, right? I'm writing wrong. Here it must be theta s minus theta. I'm doing wrong, or right? Oh, then we will get wrong, right? What is the derivation? Theta minus theta s. Okay, I will see it. Okay, I'll see it. What I'm doing wrong here, I'll see it. Okay, so
Okay.
yeah,
Sir,
yeah, tell me.
sir, yeah, that in question they are saying that the
Hmm.
block is just about to slide down, so that's the impending motion, right? And for impending motion, we can write now that tan theta s is equal to mu s. Then why can't we use that here?
Yeah, we can do that also. Yeah, you can do that also. Okay, I will see it. Okay, I will see it what I'm doing here, what I'm doing mistake. Okay, so let's solve this problem. Okay, I will look at this. Let's solve this problem. Actually, this statement is ambiguous. If if it says slide up, just about the slide up, okay, then you will get the correct answer, right? Because it is not clearly saying that whether the block, I mean the force wants to slide just up or just slide down. If it says that the block just want to slide up, then we will get this answer, I mean 0.1 cent, because that from that it will become theta plus theta s, and you will get here exactly equal to 9.80, and from that situation what mu s becomes equal to 0.17. But it is not clear whether they want to slide up or just down. That's why we are getting correct answer, I mean wrong answer. Okay, I will see it. Solve this problem. I mean this problem is straightforward, right? First you need to find theta k. And what is the theta k? Tan inverse mu k. And then you have to find theta s, and that is equal to tan inverse mu s. Okay, so in case A, so if you want to find force P, then that will become equal to what? W, I mean P. P is already given. So 800 tan 25 degree 25 degree plus theta s. And in case B, you will get 800 tan 25 degree plus theta k. And in case C, it will be 800 tan what? 25 degree minus theta s. Okay, is it clear or not?
Yes, sir, clear.
Yeah, so this is what the friction. You can also solve this problem, but since we don't have sufficient time, so you can take it as a homework. Okay, this one, and since I have already given the link, and this one also. Okay, I have already given the link of the OneNote, so you can find these two problems, since this problem is already from the gate. So but you have to solve this problem, okay, as a homework. And in the next week we will move in kinematics and dynamics. Okay, tell me.
Okay,
Okay,
sir.
sir.
Okay,
Sir,
sir.
do you have question?
What? What?
Previous coaching slides.
Previous
Slides
what?
are slide.
Your voice is
The
not clear.
previous video link. The previous video link.
Previous video link. Okay, I have already shared my YouTube channel link, but okay. I will pasting my link, YouTube channel link. Then you can see my previous video lectures. Okay, you can access my YouTube channel from this link, and you can watch previous lectures. Okay. Yeah.
Thank you.
Yeah. Okay, see you next week.
Okay, thank you.
Yeah.
Okay,
Okay.
Okay,
sir.
sir.
Thank you.
Thank you, sir. Bye.
Yeah.
Thank you.
Yeah.
Thank you.
Excellent, sir.
Thank you,
Sir,
sir.
excellent, sir. Hello, sir.
Yeah. Tell me
I want to take the question of that above question.
this question.
Yes, sir. Do we have answer? Means,
Yeah, I mean, Gate has already released the answer. That answer is 0.17. Okay. So, I solved because I assumed that they are asking the problem about the block is just about the slide down, because they have not mentioned whether they want to just about the slide up or down. But here I saw that if they ask the problem to slide down, then we will not get the correct answer, because then from that situation we will get the negative answer. I mean, theta s is negative. So from my opinion, the question must be for the sliding up. So for that situation we will get this answer. But they have, I mean, the problem, the statement is ambiguous. That's why we are not getting the correct answer. But if they have mentioned the block is just about the slide up, then we will get this answer, but they have not disclosed this point, as per my
means,
opinion. Yeah.
means for the statement of block is just about to slide, there
Up.
are two possibilities.
Yeah, slide, because there might be the block is just about the slab up or down. There might be two situations, but they have not mentioned this.
Okay.
Yeah, but I am damn sure that it must be slide up. From that you will get this answer. If they ask that the block is just about to slide down, you will not get this answer, because we are getting the negative answer.
Yes,
Okay.
sir. Yes, sir.
Yeah. Yeah, it must be slide up.
Hmm.
Yes. Okay.
Okay, sir.
Okay, sir.
Yeah.
Thank you.
Yeah. Okay. See you next week.
Thank you, sir. Next.
Yeah.